All right, so today we're diving into NVIDIA's H100 GPUs.
Oh, the H100s.
Yeah, you want to go beyond just the hype, though, and really try to understand...
Really dig in.
Yeah, the revolutionary tech behind how they built this thing.
It's really something.
So we're going to do that today.
Yeah, absolutely.
We've got you covered.
Looking forward to it. It's easy to just,
Yeah.
look at the benchmarks and hear 30 times faster, and you just kind of glaze over.
Yeah.
But the real story is how NVIDIA achieved that with the H100.
Right.
It's not just they made it a little bit better.
Yeah.
It's a fundamental shift.
Okay, so the H100 is built on this new Hopper architecture.
Right.
Help me out here.
Sure.
What's the significance of that? For someone like me who doesn't live and breathe silicon.
Right. So Hopper is like the foundation upon which everything else is built.
Okay.
And it's designed specifically for data centers.
Okay.
For handling these massive amounts of information that you need for like complex AI, scientific simulations, big data analysis.
So not just for us gamers then?
Not unless you're trying to render like a whole universe in your basement.
Okay. All right.
You know what I mean? It's for things that used to take weeks or months.
Right.
And now you can crunch that down to days or even hours.
All right. Sign me up.
Right.
So the white paper mentions something called fourth-generation Tensor cores.
Yeah.
As a key part of this speed boost.
Right.
Break that down for me.
Okay, so imagine Tensor cores are like specialized processors within the GPU, fine-tuned for the math behind AI and high-performance computing.
Okay.
The H100's Tensor cores are a huge leap forward.
All right.
They've doubled the throughput compared to the previous generation.
Throughput meaning?
Meaning they can process more information at once.
Gotcha.
And they've done this in part by introducing a new way to represent numbers.
Okay.
It's called FP8.
Okay.
Or floating point 8.
Oh, okay.
And you can almost think of it like they switched from writing with a giant marker to a superfine pen.
Okay.
It allows them to fit like 4 times the information in the same space.
Wow.
And this results in a massive speed increase.
So smaller, more efficient data representation
Precisely.
equals big speed boost.
Exactly.
Okay.
But there's another layer to this AI optimization.
Okay. Yeah.
And it's the transformer engine. This is a dedicated part of the H100.
Okay.
Built specifically for transformer models.
Okay.
Which are the brains behind a lot of the impressive AI we're seeing today.
Right.
Think advanced chatbots, powerful search engines, things like that.
Yeah.
So they saw that this particular type of AI was becoming really important.
Yeah.
And so they designed a specific piece of hardware just to make it run faster.
That's exactly it.
Wow.
Like having a dedicated lane on the highway for the most frequent travelers.
That makes a lot of sense.
Right.
And then on top of all that, we have these DPX instructions
for
dynamic programming.
Yeah.
Now, if I remember correctly from my computer science days, dynamic programming is about solving these complex problems by breaking them down into smaller, overlapping subproblems.
You got. But how does that actually play out in the real world?
Yeah.
How do these DPX instructions speed things up?
Let's say you're working on genomic sequencing.
Okay.
Okay, so you're analyzing DNA to understand diseases, for example.
Right.
The H100's DPX instructions can speed that analysis up by up to 7x.
Wow.
Or imagine optimizing routes for hundreds of delivery robots.
Okay.
Navigating a city.
Right.
These instructions make those calculations lightning fast.
So it's not just about raw processing power. It's about designing the H100 to handle specific types of problems in a smarter, more efficient way.
NVIDIA recognized that these complex workloads were becoming more important.
Yeah.
And they fundamentally changed how the H100 tackles them.
Wow.
But it's not just about faster processing. They've also completely revamped how the H100 handles memory and data flow within the GPU itself.
Now, that sounds like a story for another time.
We could talk all day about this stuff.
Before we move on to that, though.
Sure.
Can you tell me a little more about this thread block cluster concept?
Yeah.
I read something about it being like a new level in the programming hierarchy.
It's all about efficiency.
Okay.
So imagine a group of threads all working together on a task.
Okay.
They're like a team within the GPU.
Right.
Now imagine a whole bunch of those teams working together on an even bigger task.
Right.
That's essentially what a thread block cluster is.
So instead of everyone trying to do everything at once, you've got these specialized teams working together.
You got it.
In a more organized way.
This new level of organization allows for much finer control over how those teams, or thread block clusters, collaborate and share data across the GPU.
Gotcha.
Making everything run much smoother.
So it's like going from a bunch of individual workers to a well-coordinated factory floor.
I like that analogy.
Right.
Yeah. Yeah.
That makes a lot of sense.
It does.
Now, before we get into the nitty-gritty of memory and data flow, can you tell me a bit more about what makes the H100 asynchronous?
Ooh, okay.
I think I keep seeing that term thrown around.
Yeah, it's a game changer.
Okay.
So think of it like this.
Yeah.
Imagine you're working on a project and you need information from someone else.
Right.
In a traditional system.
Yeah.
You'd have to stop what you're doing.
Right.
And wait for them to get back to you. But with an asynchronous system,
yeah,
you can send the request and then keep working on other tasks while you wait.
Oh, okay.
The H100 is NVIDIA's first truly asynchronous GPU.
So it can multitask on a whole new level.
Exactly. It can overlap data movement, computation, synchronization.
Wow.
In ways never before possible.
Okay.
Which leads to some serious efficiency gains.
I can imagine.
Yeah.
But how does that actually work in practice?
Right.
What are some of the key components that make this asynchronous magic happen?
Right. One of the key players here is the Tensor Memory Accelerator.
Okay.
Or TMA for short.
Okay.
It's like a dedicated high-speed rail line.
Okay.
For moving large chunks of data within the GPU.
Okay. So instead of data getting stuck in traffic with everything else,
exactly,
it's got its own express lane.
It's got its own express lane.
That's pretty cool.
And because the TMA operates asynchronously,
right,
it can be moving data in the background.
Okay.
While the tensor cores are busy with their calculations.
Oh, wow.
So no more waiting around for data to arrive.
Gotcha.
Everything keeps humming along smoothly.
That's pretty slick.
Right.
But with all this asynchronous activity going on,
yeah,
how do they keep everything in sync?
Right.
It seems like it could easily just turn into a chaotic free-for-all.
That's where the asynchronous transaction barrier comes in.
Okay.
So it's like a traffic signal.
Okay.
For all this asynchronous activity.
Gotcha.
Ensuring that different parts of the GPU can synchronize their work efficiently.
Right.
Even if they're operating on different schedules.
So it prevents everything from grinding to a halt?
That's exactly it. Every time something needs to be synchronized.
Yep, keeps those synchronization points to a minimum.
Gotcha.
Which is crucial for maintaining that speed.
Right.
Now, speaking of things that can slow things down, even with the most efficient processing and data flow,
yeah,
you're still limited by how fast you can feed information into the GPU and store the results.
It's like having a super fast kitchen but a tiny refrigerator.
Yes.
You can only cook as fast as you can get ingredients in and out.
Perfect analogy.
Right.
And that's where the H100's memory subsystem comes in.
Okay.
They're using the world's first HBM3 memory.
Okay.
Which stands for high bandwidth memory.
Right.
Think of it as the ultimate high-speed data pipeline.
Okay. But how high bandwidth are we talking here?
We're talking about a massive 3 terabytes per second bandwidth. Yeah, terabytes per second?
Yes.
That's mind-bogglingly fast.
It's double the bandwidth of the previous generation.
Really? Yeah.
Imagine going from a dirt road to a superhighway.
Wow. Okay.
That's the kind of leap we're talking about.
So we've got lightning-fast processing, a super efficient way of moving data around inside the GPU.
That's right.
And now this massive pipe for feeding it all with data.
Yep.
They really thought of everything.
They did, and let's not forget the larger L2 cache.
Oh, right.
That's like the GPU's short-term memory.
Okay.
Storing frequently accessed data.
Right.
So it doesn't have to keep going back to the main memory every time.
Right, like having your most used tools right there on your workbench.
Exactly.
Instead of having to dig through the toolbox every time.
Exactly.
Okay.
It all adds up to a level of performance and efficiency we've never seen before in a GPU.
Wow.
But all this power is useless if it isn't accessible and secure.
Good point.
Right.
What good is a supercomputer if you can't actually use it for anything?
Exactly.
So how does the H100 shape up on the security and virtualization fronts?
NVIDIA has made some major strides in these areas.
Okay.
For example, they've introduced second-generation multi-instance GPU technology.
Okay.
Or MIG for short.
Yeah, okay.
Imagine you're running a cloud computing service.
Right.
And you have multiple clients who all need access to that powerful H100 GPU.
Right, but you don't want them all
Right.
fighting over the same resources, or worse, seeing each other's data.
Exactly. That's where MIG comes in.
Okay.
It allows you to partition the H100 into up to 7 independent and isolated GPU instances.
So it's like dividing that massive GPU into smaller virtual GPUs.
Exactly.
Each with its own dedicated resources.
That's a great way to put it.
Right.
And to ensure each virtual GPU can handle its tasks efficiently.
Okay.
Each one also gets its own dedicated NVDEC and NVJPG units.
Okay, those acronyms are coming back to haunt me.
Right.
Remind me what those do again.
Okay, so NVDEC is dedicated to decoding video.
Gotcha.
And NVJPG handles JPEG image decoding.
Right.
These are tasks that can eat up a lot of processing power.
Yeah.
So having these dedicated units for them frees up the rest of the GPU
to
focus on other things.
It's like having specialized chefs in a restaurant kitchen.
Exactly.
One for prepping vegetables, one for grilling meat.
I love it.
Everything runs more smoothly?
It ensures that each client, using the H100, gets dedicated hardware acceleration for those data-heavy tasks, maximizing both performance and security.
Right, because they're not all sharing the same pipeline.
But speaking of security, the H100 takes it up a notch with something truly groundbreaking.
Confidential computing.
Confidential computing. Okay, that sounds like something straight out of a spy movie.
It's about addressing a critical vulnerability in traditional computing. Protecting data while it's being used. We have encryption for data at rest. Like when it's stored on a hard drive. And in transit, when it's being sent over the internet. But what about when that data is actually being processed by the GPU? That's where it's most vulnerable. Because in a normal setup, the operating system or the hypervisor could potentially access that data.
Precisely. But the H100's confidential computing creates a hardware-based, trusted execution environment, or T, within the GPU itself. Think of it as a secure vault. Where data can be processed without being visible, even to the host operating system.
So even if someone hacked into the main system, the data being processed within that secure vault would still be protected.
Exactly. It's a game changer for security-sensitive fields. Like healthcare, finance, government. Opening up a whole new world of possibilities for running sensitive workloads on shared infrastructure.
That's amazing.
And it doesn't stop there. Remember those super fast NVLink connections we talked about earlier?
How could I forget?
Which allow the GPUs to talk to each other.
It's like the superhighway connecting all the different parts of a city.
Well, the H100 introduces something called the NVLink switch system. Which takes that connectivity to a whole new level. Now, instead of just connecting GPUs within a single server, you can connect up to 256 of them across multiple nodes. Creating this massive interconnected network of processing power.
Whoa, so we're talking about building supercomputers the size of buildings with these things.
Precisely.
Wow.
And because these NVLink connections are so fast, the performance scaling is incredible. You essentially multiply your processing power with each H100 GPU you add to the system.
That's incredible. So with all these groundbreaking features, from its revolutionary architecture to its unparalleled security measures, it's clear that the H100 is more than just a faster GPU.
Absolutely.
It's a paradigm shift in high-performance computing.
It really is.
But before we get ahead of ourselves, let's not forget one crucial aspect.
You're talking about the software, right?
Exactly. Even with the most amazing hardware, it doesn't matter. It's meaningless if developers can't actually use it.
They gotta be able to program the dang thing.
Exactly. It's like having a race car with no steering wheel.
Exactly.
All that power is useless if you can't control it.
That's right.
So how has NVIDIA addressed the software side of things with the H100?
Well, they've made some significant updates to their CUDA platform, which is essentially the language that developers use to talk to the GPU.
It's how you tell it what to do.
Exactly.
Gotcha.
And so, just like the H100's hardware is designed for efficiency and performance, the updated CUDA platform gives developers the tools and libraries they need to unlock that potential.
So instead of having to start from scratch and figure out how to wrangle all these new features, CUDA gives them a head start.
Precisely. There are new functions and libraries specifically designed for things like those thread block clusters and asynchronous features we talked about. So developers can just write more efficient code with less effort.
Gotcha.
Freeing them up to solve bigger problems.
That makes a lot of sense. We've covered a lot of technical details here. I think it's time to bring it back to the real world, though. What are some tangible ways that the H100 can be used to solve real-world problems?
The applications are incredibly diverse and impactful. It has the potential to revolutionize fields like scientific research, medicine,
Wow.
and even help us tackle climate change.
Okay, now those are some big claims.
Yeah.
How can a GPU, even one as powerful as the H100, make a difference in something as complex as climate change?
Well, think about climate modeling.
Okay.
These simulations.
Yeah.
They require immense computational power to process vast amounts of data and make accurate predictions.
Okay.
The H100, with its speed and efficiency, can significantly increase the resolution and accuracy of these models, giving scientists better tools.
So we could be talking about more accurate weather forecasts?
Potentially, yeah.
A better understanding of long-term climate trends?
Exactly.
And potentially even new ways to mitigate the effects of climate change.
It's possible.
Wow.
And that's just one example.
Right.
In medicine.
Yeah.
The H100 can accelerate drug discovery.
Okay.
By simulating molecular interactions at an unprecedented scale.
Right.
Potentially leading to faster development of new treatments and cures for diseases.
That's incredible.
Yeah. It's pretty amazing stuff.
It sounds like the H100 is more than just a technological leap.
Right.
It's a tool that empowers us.
I like that.
To tackle some of humanity's biggest challenges.
You think that's a great way to put it?
That's amazing.
Yeah.
This has been an amazing deep dive into the world of the NVIDIA H100 GPU.
Really impressive technology.
We went from the inner workings of its architecture to its potential to revolutionize entire industries.
Yeah. And what's most exciting is this is just the beginning.
Right.
As developers continue to explore and unlock the H100's capability.
Right.
Who knows what incredible breakthroughs await us?
It's an exciting time to be following the world of technology. That's all the time we have for today's deep dive, though.
Okay.
But I encourage you to keep exploring.
Absolutely.
The H100 is a powerful example of how innovation can lead to amazing possibilities.
Couldn't agree more.